In this video, we're going to be solving a first-order differential equation using the integrating factor method. So in this example, we're solving dy by dx plus 2y is equal to e to the minus x, with the initial condition y of 0 is equal to 1. So the first step is to compare this with the general form that we need for using integrating factor. So is it in the form dy by dx plus some function of x times by y is equal to another function of x? So if it's not in this form, we'd first have to rearrange the equation to get it into the correct form. So for example, if we had a coefficient for dy by dx, we'd have to divide by that first to make sure that the coefficient is 1 and it's in the exact same form. So from here, we can see, comparing with the equation, that p of x is equal to 2 and q of x is equal to e to the minus x. We can now identify the integrating factor. So our integrating factor mu of x is always equal to e to the integral of p of x dx. So we always make this choice of integrating factor because it's going to allow us to use a trick later on to rewrite the left-hand side as the derivative of a product. So here we said that p of x is 2, so our integrating factor is equal to e to the integral of 2 dx, which is equal to e to the 2x. The next step is to multiply through by our integrating factor. So we multiply everything in that differential equation by the integrating factor mu of x. This gives us e to the 2x dy by dx plus 2e to the 2xy is equal to e to the x. If we've chosen the integrating factor correctly, we should always be able to see that that left-hand side is now the result of differentiation using the product rule. So we should always get that d by dx of the integrating factor multiplied by y is equal to the integrating factor multiplied by that function q of x. So in this case, we've got d by dx of y e to the 2x is equal to e to the x. We can now integrate both sides. So on that left-hand side, the integral will cancel with the derivative, leaving us with y e to the 2x. And this is equal to the integral of e to the x dx, which is still e to the x plus c. So dividing by that integrating factor, the e to the 2x, this gives us y equals e to the minus x plus c e to the minus 2x. And here we can apply the initial condition, y of 0 is equal to 1, and solve for y. So replacing the x's with zeros and the y with 1, this becomes 1 equals e to the 0 plus c e to the 0. And since anything to the power 0 is 1, we get that c is equal to 0. Therefore, the final solution is y is equal to e to the minus x.